Okay, we are going to continue now the exercise we've been providing, and this I will go now. I will try to be more efficient, not to analyze with all detail all the alternatives, so that we start to be aware of how quick and efficient solutions can we obtain with all the financial mathematical formulas we could have. Okay, let's go into the exercise again, and let's have a look at this. These are the previous exercise already solved. Let's have a look at this simple exercise. Okay, what we have here is a proposal for a credit. Okay, we borrow money initially. Okay, and we want to know how, how costly is this investment. Okay, let's see what is the present worth. Present worth of the proposal is equal to minus 5,000, the money we borrow, we're in debt for this, plus, okay, the 5 equal annual payments already known. So what is the value, the present value of this? We use the formula, we know, okay, with the first attribute is the annuity we have to pay, the second attribute is the R, the rate of discount, we don't know which one has been charged, and the number of periods is 5. Okay, so balancing this, actually saying, okay, the present worth of the money you receive is equal to the present worth of the money you pay for a given rate of discount. This is the rate of interest you've been paying when signing this contract. Okay, how to solve this in Maxima? Okay, pretty simple. Okay, give me present worth will be equal, okay, we define this function, plus P for A the expression, the formula is pre-cooked, and now we can obtain the result directly. Let's go straight forward to the graphic. That's the best solution. Plot 2D of P W P R plus R. I'm sorry, this is in brackets. R. So let's presume 0.20. That's good enough. We can. I always like to introduce the grid. Okay, and we get the plot. So look, oh, we overestimate this is 200, so I should say, okay, now that's better. Okay, something between 5, this is probably around 6%. Okay, this is the rate of interest that balances these two components of the cash flow and makes this equal. To be more precise, I can always use this expression, okay, minus 5,000 plus, how many payments are there? Okay, 5 payments of this time we're going to do it directly. Enter, comma. Let's introduce an initial seed. So it's 6.4, the internal rate of discount. Again, this represents, okay, the equilibrium between these two terms, but can be also considered as a comparative. If the rate of interest you obtain in the market is, let's say, 3%, this is, okay, you're paying too much. Okay, we call this, the amount we pay is now positive. Okay, if we switch the fear and the things, this will represent our debt. So what we have here is that if the bank is charging actually 3%, we are paying 500 of extra cost. If the bank is charging 15%, we are saving all this amount. Okay, so if the bank charge exactly 6.5, then 6.4, then we are paying exactly the cost of the bank. Okay, quite clear. Let's have a look at this exercise that is also interesting. Okay, this is the typical situation for a student in the States. Okay, you have a credit you obtain from the university and you have to pay back, I presume. Okay, then the situation is this. During 4 years, you receive, I will first plot as always. This is the y-axis. During 4 years, you receive $8,000. Okay, this is the amount you receive, 8,000 per year. From year 1, 2, 3, and 4. You graduate at this moment. Okay, and from this moment, the bank waits until next payment, and you have to pay back a given annuity. Okay, that you still don't know how much is it. Okay, four, 5, 6, 7, 8. Okay, a constant annuity here. There it is. But this annuity is unknown. How can we calculate this? The idea is that the bank is not charging anything. So your debt until this moment is 8,000 times 4. So I will draw now in red your actual debt. And your actual debt for the contract, your debt here is 32,000. The scale is different. Okay. And this annuity is calculated on a basis of 5%. Okay. So let's crop it. Okay. Okay. Okay, sorry for interruption. Okay, so first problem, what is the annuity that you are gonna pay? So let's first solve the problem in theory and then we'll go into the formulas. We will have an annuity that reimburses this credit. So the function we need is give me the annuity provided I know the present value. The present value is 32,000. Okay, 8,000 times 4. The rate of discount is unknown for the moment, the rate of interest, but the rate charged by the university is 5%. We're being asked a different thing that we'll see later on, and the number of periods is 5. Okay, So give me this function, and I will know the annuity. Let's compute it. Okay. Then this is what the university is going to ask you. Give me 5 payments of 7,391. Okay, so we know more about this now. I will switch the color again to black. So this is 7,091 dot 90. Okay, so this is the annuity you have to pay in order to make a note of this. But this is the way the university has calculated this value. But now we have to notice that you've been receiving money previously. So what is the actual cost of this project? What is the actual rate of interest you're paying? It's not this 5%. This 5% has been used just to compute this. But actually you receive the money here, a different previous in advance. So it has to be lower than that. So how to handle that? Okay. We can first obtain the present worth at any moment we like. Okay, present worth of this. For example, the present worth. Okay, sorry, I will open a new formula. Present worth of the credit is equal to P over P over A. Present value of this annuity of 8,000 with an unknown rate of interest during 4 years. Okay, and this will be reduced, taken here, plus the present worth of these 5 payments plus P over A of these 5 payments whose value we know now for an unknown rate of interest we have to determine during 5 years. Okay, but this will reduce all these payments to its present equivalent. It's not 32,000 because we don't know what the actual rate of interest has to be. Okay, then what we have to do now is to take it to the present, and to do this we introduce this value as an argument for the new formula, present value of a future value. Okay, sorry, I will copy this inside the brackets. Okay, during how many years? 1, 2, 3, 4 years delay with a rate of discount unknown. Okay, so this will give us the present worth of the project. Let's copy this here. No, sorry. Okay. Okay. Sorry. PWC. I'm using these funny names just to be sure that in the same session of maxima there is no repeated value. This is a function of R. Okay. Sorry, this in maxima we have to compute this. Okay. Remember that in maxima this slash has a meaning, that is division. Okay, and now this is the function. We can now solve as previously dm plot to the PWC of R sorry, R 0. Okay, let's presume that is okay. 15% is enough. Okay, and so let's add the grid. That is always interesting to compare. Okay. Oh, this is sorry. There is a mistake here. This is a minus 8,000. So this is a minus 8,000. Then we can obtain that. So, okay. This is the value now. And see, oh, it's quite a good investment. We're actually paying between 2 and 3%. Oh, that's good. Okay. So 2-3% will balance the money we receive with the financial cost against the money we have to pay back. So that's pretty good. But what is the actual value? Let's be more precise. Okay. Here we will introduce then minus 8,000, minus 8,000, sorry, minus 8,000, negative, comma, minus 8,000, comma. Okay, we're here. Then I will copy the value to be sure I don't make a mistake. Five payments. Okay, so this is the list. 1, 2, 3, 4 grants received, and 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 payments we do. So 10 as a guess. And we see that there are two solutions. The negative discount is something around 3.2%, 3.26. Actually, the rate of interest we're actually paying. Okay. So this look that just programming this expression that reduces everything to one initial payment. Okay. At this moment. Okay. Sorry. No, that's sorry. That's there's something wrong. We have obtained the annuity is here. So there are 5 steps. 1, 2, 3. No, it's okay. 4 steps until the new payment. Okay, that's good. So we again can say you're actually paying 3.2. If you go to the bank and obtain a credit with 3.2 or something, 24, 25 rate of interest, you will be paying the same to the bank than to the university. Okay? Okay. And to finish this seminar about the internal rate of return, let's review this more geometric exercise in order to be more to have a more familiar approach to the problem. Okay, come here. Hey, where are you going, my dear? Okay, these are the horizontal axes. We're not clearly seen. Okay, so these are the 3 cases we need to face. Let's have a look at the first one. What we have here is a typical financial operation. We either deposit this 5,000 in the bank and we receive these payments, or the opposite. We receive this amount of money from the bank and we have to pay with this annuity. So again, let's follow this expression as always. Okay. This is a typical financial contract. We'll open the formula, and the formula is saying the present worth of this, worth of A, is equal to, let's say, minus 5,000, or plus, let's follow the rule, plus 5,000, plus the present worth of this annuity that we know is minus 1318.99, okay, during 1, 2, 3, 4, 5 payments, 5 years. Okay. It's easy to handle. Let's now open here Maxima. Oh yeah, it is open there, but and the model will be very simple.